Okay, now we're going to do practice D. Practice D, these are all problems, even though we're using conservation of momentum, they're called recoil. So recoil, when you think about it, is, have you ever seen, even if you didn't see in real life, you've probably seen a cartoon on TV where there's a cannon and a cannonball. They're both initially at rest. So what happens is when the cannonball shoots one way, the cannon goes back in the opposite direction, and that's called recoil. When people who shoot a gun, I've never shot a gun, but when people first shoot a gun, because the gun and the bullet are initially at rest, when you shoot it and the bullet, even though it's small, it goes really fast, what happens is it causes the gun to go back. So if you're not used to holding a gun and expecting and anticipating that recoil of the gun, you're going to kind of like fall backwards. So that's what recoil is all about. So those are just a few examples. So all of the problems in Part D, even though we're doing conservation of momentum, either the velocity of both before 0 or after 0. So these are recoil problems. So let's do practice number 1 together. So number 1 says a 63-kilogram astronaut is on an open spacewalk when the tether line to the shuttle breaks. The astronaut is able to throw a spare 10-kilogram oxygen tank. So I'm going to call this MA, and I'm going to call the oxygen tank B. So I have the masses of both. So he throws it in a direction away from the shuttle with a speed of 12 meters per second. So initially, now let's conceptualize and picture this. Initially, the astronaut and the tank are both just sitting there. Neither one is moving. When he throws the tank one way, what's going to happen is he's going to go back the other way. Okay? So when they tell you that he's able to throw it away from the shuttle with a speed of 12, that's going to be VB prime, because that's the speed of the tank after he throws it. So that comes out to be 12 meters per second. Propelling the astronaut back to the shuttle. Assuming the astronaut starts from rest, find his speed with respect to the shuttle after the tank is thrown. So the velocity of the astronaut before is 0. The velocity of the tank before is 0. And what we want to find is we want to find the velocity of the astronaut after, which is going to be VA prime. So conservation of momentum says the total momentum before is equal to the total momentum after. So the total momentum before is going to be MA VA plus MB VB. And if you want, go ahead before and say PA plus PB is equal to PA prime plus PB prime. If you want to write that step out, there's nothing wrong with that. Now, do you see the equal sign in the equation? The equal sign is the event. What do I mean by the event? The equal sign is the astronaut throwing the tank. The equal sign is if I have two objects and there's a collision, like cars crashing, the equal sign is the crash. So the equal sign is what's happening in between the before and the after. That's what the equal sign represents. So then this is equal to MA VA prime plus MB VB prime. Now, with recoil problems, again, the astronaut and the tank are just sitting there while he's holding it. Nobody's moving. So because the VA and VB are 0, both these terms go to 0. So now, here's my equation. This is 0, and I'm solving for VA prime, which is this. So I'm going to leave that on one side of the equal sign. I'm going to move everything to the other side. So when I move this to the other side, I have negative MB prime, and then I'll divide by MA. Now, some people just like to memorize stuff like that. You don't want to memorize equations because sometimes I'm solving for VA prime. Sometimes I'm solving for BB prime. So you don't want to just like memorize this. That's not going to help you. Do you understand just understanding it in layman's terms helps you? So you're not memorizing 20 different equations. Here's my one thing. So now I'm going to substitute in my values. So it's going to be negative 10 kilograms times 12 meters per second divided by 63 kilograms. So now when I do this on my calculator, 10 times 12 divided by 63 comes out to be 1.90, negative 1.90 meters per second. So the negative sign means that the astronaut is going in the direction opposite that he threw the tank in. Now, let's just thinking about conceptually, that makes sense. You know, he throws the tank one way, and he goes back the other way. So in all of these problems in practice D, you're going to have where the initial velocity is 0. So that's the trick to these problems. It's not a trick, that's just... Now remember, in the practice problems, they all do the same thing, but then once we get to the other problems, the mixed reviews, they're all mixed up. And that's it.